All right, good afternoon, everyone. I'm about to go ahead and get started here. So welcome to this Engineering Ethics Pdh seminar. As it shows on the screen, hang on, I'm just admitting people. As it shows on the screen, this meeting should be worth 2 Pdh credits or zero point 0.2 continuing education units. I will want to emphasize that you can either receive Pdh or CEU for this meeting, not both. And I will go through the process of how you select which of those. Our presenter this today will be Dr. Mohammed Safiuddin. I know I'm gonna have some difficulty pronouncing that name, so I asked for Dr. Safiuddin's forbearance and forgiveness with that. Just some housekeeping information before we get started. So this presentation is put on by the IEEE Iowa, Illinois section, and I invite you to follow us on social media or the main hub through which we communicate most of our announcements to the general public is actually our Facebook page at iowa.illinois.ieee. I am your chair, or the chair of the section, Judah Richardson. You can find me at linkedin.com/in/Judah Richardson. Our professional engineering residence is Becky Watkins. She's not here yet, but you can find her at Becky W8 on LinkedIn. And then our chair of the Power Engineering Society group is Jose Villarreal. You can find him at jose-i.villarreal. And then we want to give a good thank you to Region 4, which is the upper Midwest of the IEEE. They helped us promote this event and put it on. You can find them at r4.ieee on Facebook, and then also on at linkedin.com/company/IEEER4, and also on Twitter at IEEE.R4. I'd also like to invite everyone who is currently attending to hang out with us. We have regularly scheduled events throughout the year. We have socials. The first Wednesday of every month at 6 p.m. at U.S. Central Time is our Power Hour. That's our Power Engineering Society and Women in Engineering online meetup. You may wonder why we're still doing online meetups in November of 2021. The reason for that is that when we started this during the pandemic, we started getting engagement from as far away as Colombia. And so we realized that that was something we did not want to have go away. And so now that meeting continues to be virtual. If you want to meet with us in actual person, we do that on the third Friday of every month at 5:30 p.m. U.S. Central Time. It's called Cyber Social. That meeting revolves around the Computer Society and cybersecurity, and it's at Tanglewood, which is a really wonderful venue at 3636 Tanglewood Road, Bentdorf, Iowa, 52722. Really fantastic. They have both indoor and outdoor sections and a really beautiful beer garden. So we encourage you to join us there. As far as annual conferences are concerned, we have our annual Corncon Cybersecurity Conference, which will be in its 8th year in 2022. That takes place in the fall, usually either in late September or early October. You can find out more about it at corncon.net and also follow it on Facebook at QC Corncon and also on Instagram at Corncon Cyber. So here's, of course, what the majority of the attendees here will be interested in, which is how to receive the Pdh or CEU credit. So as I said before, attendees will receive only Pdh or CEU credit, not both. To receive credit, I'll need you to go to the event page, which is the same one that you registered at. Scroll down, and then following the instructions that are shown in this picture. This is literally a screenshot directly from that page. I'm sorry, didn't mean to advance the slide. This is literally a screenshot directly from the page. So just follow the instructions there and it'll be just fine. I know a lot of you are curious as to how the process goes. So the first step of the process is that the attendees complete the questionnaire, which is at the link in the previous slide. The link is actually on the actual event page that you go to. And then also complete the evaluation form. The questionnaire gets rolled into a Google Forms that we can then export to an Excel spreadsheet that the mothership requires. And we also need you to complete the evaluation form. Once we have both of those, once we have both of those from you, we'll generate the attendance roster spreadsheet, and then we'll submit both the attendance roster spreadsheet and the received attendee evaluation forms to IEEE. And then afterwards, IEEE will email the credits that you requested to you directly. I know, I understand that a lot of people have a November 30 deadline regarding this, and so I encourage you to go ahead and get this done as soon as possible. The questionnaire, it's basically just your name, your address, and how to get in touch with you. So if you want to go ahead and complete that as soon as possible, that would be really appreciated. Ideally, what we want to do is that we want to get these, get step 2 of the process done by next Monday, so that the mothership, the IEEE mothership, can get your credits out to you as soon as possible, so that you can meet your end of month deadline. Now to introduce our speaker. So if I were to go through all of Dr. Safiuddin's accomplishments, I think we'd still be here tomorrow. There are a lot. He has accomplished a lot over a very long time, and this slide actually barely scratches the surface of all he's done. Dr. Safiuddin has a career that spans 62 years and 2 continents. He's a research professor emeritus at the University of Buffalo Electrical Engineering Department. He's the president of STS International, and his honors include both being an IEEE Life Fellow and a University of Buffalo Engineer of the Year for 2020. His technical interests are control systems, grid and power, and also technology management. I think I speak for all of us when I say we're pretty eager to hear from Dr. Safiuddin, and so now I will turn it over to him so he can begin sharing his screen and begin his presentation. Go ahead, Doctor.
Okay, thank you very much for the wait a minute. I had the first part 1. What happened to my part 1? We just had a part 1 out. Here it is. Okay.
I was about to say, I know it's there. I saw it.
I know.
We
Yeah.
practiced before this all started, so
Okay.
it's there.
Well, good afternoon, and thank you for the opportunity to share some thoughts with you people. The topic is ethics and social responsibility for a better world. As I was introduced, my name is Mohammed Safiuddin. I'm a Life Fellow of the IEEE, a research professor at the University of Buffalo, and also president of STS International. I live in the suburb of Chicago, Plainfield suburb, and my email address, if you need to, stsintl92@gmail.com. What we're going to do is public perception of ethics and honesty of professionals. So this is basically done every year by Gallup, looking at it. And if you look at this chart, nurses, for example, have the 84% rating of highly, trustworthy, honest, and
Hey, Dr. Safiuddin, sorry, you're on mute. Hey, sorry, you're on mute. I had to mute some people because I was getting background noise. So my apologies. Just unmute yourself. You should be able to talk. It should be at the bottom of the main WebEx screen. Or you should see a pop-up saying asking you to unmute. Hey, doctor, I think we're still unable to hear you.
how about now?
Yes, now we're able to
I
hear
don't
you.
know what
Thank you very
happened,
much.
how it got
I think I'm gonna go ahead and
Okay,
make your
here.
co-host.
Can you
Yeah.
hear me now?
Yes. Yes. Yep. We can.
And can
Thank
you
you
see
very
the
much.
screen?
Yes.
Yes, we can see your screen now.
Okay. Sorry about whatever happened. I don't know what happened. Anyway, when it comes to engineering reputation in terms of their honesty and integrity, the latest data is 2019 December 2 to 15. 17% very high, 49% high, 31. So basically, we have a good 66% very high and high, regard for the engineers in terms of trustworthiness and honesty in the professional ethics. So these are basic data. As you can see, it varies year to year, but most of the time we are about, above 60. And this is available at Gallup Honesty Ethics Profession. You can go to the website, get an update on it if you want to. What I want to talk about is really what is the role of engineer? Then go through some historic background on ethics and some personal experiences. Then I would like to go over codes of ethics for engineers, both national and international. Then we look at the global environment. I call 3 Ps: people, planet, and profits. We look at social responsibility, ethical constraints on design optimization. Then we look at some case studies. Then I'll just give you some brief conclusions and observations. And then there's a nice quote by Ralph Waldo Emerson I like about on success that I like to share with you. As an engineer, based on our academic qualifications, we either have associate degree certification, BS or BTech, and generally our job function involve design engineering, sales, application engineering, testing, systems operation, and troubleshooting. Then when we go to graduate school and get MS or MEng or MTech, we get more into applied research, product development, application engineering, and consulting. Then when we get another advanced degree in PhD or doctor of engineering, we get into basic research, teaching, technology development, and faculty development consulting. This is how our basic job functions are related to our academic qualifications. Now, like doctors, lawyers, and teachers, our basic mission is of any profession is to make life happier, healthier, as many as possible, for as many people as possible through their skills and know-how. This is what we necessarily consider our role to be. And have been known for centuries to be the builders of societies and not their destroyers. They respond to what people want to read or need and do not dictate as to what they should want, where no need exists, just for financial gains. So, we have the engineers have been basically the main people who have basically advanced the civilization throughout centuries because of their innovation, because of their design, because of their participation. What I like to do is just basically quickly look at the historical background on ethics and personal experiences. As we look into the rearview mirror of human history, the earliest code of ethics is found in the 7 laws of Noah Shide of the Prophet Noah's period around 3000 BC. Number 3 and number 5 deal with social responsibility, forbidding murder of fellow humans and stealing from them. Then Zoroastrianism was revealed to Prophet Zoroaster, who lived in Persia during the period of 1800 to 1100 BCE. The Zoroastrian creed and ethics are based on 3 basic tenets and practices: Umta, good thoughts; Pukhta, good words; Urashta, good deeds. The next set of code ethics is found in the well-known 10 Commandments of Judaism, of Prophet Moses' period around 1280 BC. 4 of the 10 commandments of Moses: thou shalt not kill, thou shalt not steal, thou shalt not bear false witness against thy neighbor, thou shalt not covet thy neighbor's house or anything it belongs to the neighbors. These have also been accepted as fundamental laws of ethics and morality in Christianity, with different versions adopted by the Catholic and the Protestant branches. Besides a complete chapter on Prophet Moses and mention of him and the children of Israel in several other chapters, Islam's holy scripture, Quran, reaffirmed the 10 commandments given to him on the tablets. The Holy Quran of Islam also has verses referring to Prophet Shoaib, father-in-law of Moses, Jethro, according to biblical scholars, pertaining to preaching to the people of Midian for honesty and weights and measures. When they did not heed the warnings, a powerful earthquake swallowed them. The time frame appears to be the same that of the Moses. Now, the Holy Scripture, Hinduism, there are more than 1 billion people in India, dating back 2000 to 1000 BC, also offer a similar list of yamas and niyamas. Yamas means do's and niyamas do's and don'ts. A few of them are listed here. Ahimsa, non-injury. Don't harm others by word, deed, or thought. Refrain from lying and betraying promises. Do not steal, covet, or enter into debt. Restrain from intolerance and ill will. Overcome fear, indecision, and ficklessness. Conquer callous, insensitive feelings. Renounce fraud, cheating, and stealing. Observe purity of the body, mind, and intellect. Be modest and show remorse for misconduct. According to Hindu ethics, one cannot have a progress in a spiritual path without it. It is defined as the foundation of yoga and cornerstone of Vedanta. As a comparison, it further states that every religion has its ethics. The Sermon on the Mount of Jesus and the 10 Commandments contain ethical teachings for the uplift of man. The Noble Eightfold Path of Buddha is the essence of ethics. The Yamas and Niyamas of Patanjali constitute the highest ethics. Manusmriti and Yangtila Smriti and Parsarat Smriti contain the code of conduct of man. The 3 kinds of austerity of the Gita are also in the same, nothing but ethics at intensified form. Now, Chinese ethical values can be traced back to Confucius, Latinized form of the Chinese Kung Fu, Master Kung, around 6th to 5th century BC. Though not professed as a religion, his philosophical influence has been widespread in China and neighboring countries of Asia Major for over 2 millennia. There are 5 virtues in belief and practices of Confucianism. These 5 virtues teach the followers of Confucianism the basic ideas about how a person should behave. The first virtue is Ren, which is humanness. Humanness can be defined as the quality of compassion for others, which can include both people and animals. 3 of the key concepts of Ren are love, mercy, and humanity. The second virtue is Yi. Yi means honesty and righteousness. The third virtue is Li, which means propriety and correct behavior. The fourth virtue is Ji, which stands for wisdom and knowledge. The fifth one is Jin, which stands for fidelity and sincerity. At the peak of Greek civilization, we find virtue ethics of Aristotle. He was a student successor of Plato at the Plato Academy in Athens. According to Aristotle, things of any variety have a characteristic function that they are properly used to perform. The good for human beings then must essentially involve the entire proper function of human life as a whole. And this must be an activity of the soul that expresses genuine virtue or excellence. Thus, human beings should aim at a life in full conformity with their rational natures. For this, the satisfaction of desires and acquisition of material goods are less important than the achievement of virtue. A happy person will exhibit a personality less a personality appropriately balanced between reasons and desires with moderation, characterization. In this sense, at least, virtue is its own reward. True happiness can therefore be attained only through the cultivation of the virtues that make a human life complete. Fast forward to 15th century AD, we find ethical teachings in the religion of Sikhism, founded by His Holiness Guru Nanak Ji, to preach unity of God and universal brotherhood. It abolished the evils of caste system and gave spirit of saint soldier among the followers. Besides reciting God's name and meditation is remembrance, the ethical codes of Sikhism require kirat karni, earn your living by working hard and honestly. Wand chakna, share with others the fruit of your exertions. Shubkaram, doing righteous and good deeds. Their way of life is the life of contemplation, love, and service. Gyan, Prem, and Seva. The question now arises as to the moral ethics of atheists. What moral code do they use to guide their social behavior? We may find the answer in the Ethics Without Religion. There's a website for it. The task, and this is the quote from there, the task of moral education then is not to inculcate a road great list of do's and don'ts, but rather help people to predict the consequences of actions being considered. What are the long-term as well as immediate rewards and drawbacks of the acts? Will an act increase or decrease one's chances of experiencing the hedonic pride of love, beauty, and creativity? Thus it happens when the atheist approaches the problem of finding a natural ground for human morals and establishing a non-superstitious basis for behavior, that appears as though nature has already solved the problem to a great extent. Indeed, it appears as though the problem of establishing a natural humanistic basis for ethical behavior is not much of a problem at all. It is in our nature to desire love, to seek beauty, and to thrill at the action of creation. Based on this review of the historical background on the ethical conduct, we find that three key codes of ethics, fundamental acceptable human behavior throughout times and cultures have been not to steal or rob, directly or indirectly, not to kill or harm people, other creations on the planet, to achieve a virtuous life and serve humanity to the best of one's ability. While greed remains the main driving force for maximizing financial achievements of individuals' communities, it must be constrained by these fundamental ethical codes if we are to leave a better and more peaceful world for our children and grandchildren. So this is really, if you look back, ethics is not something it brings in one religion or another religion. It's throughout the geographical boundaries and throughout the religions, throughout the time periods. There are certain basic codes. We call them as ethical behavior, ethical codes. Now, I want to share some personal experiences about what I must have ran into. I graduated from engineering college in 1958 in India, and my first job was as a junior engineer. At that time, there was a big push to what they call the rural electrification, bringing electricity to the villages of India throughout. So I was appointed as a junior engineer in the construction operation department in a village. I was in charge of 3 villages to basically get the homes and businesses electrified while the main transmission line was still coming through while being under construction. So that once if the village is already has got completely done, we could just go ahead and connect it. So I was away from my city, my own birthplace, but a village quite away from my home. And of course, this was my first appointment there as a young 21-year-old. There was no office. It was just in the beginning. And there were 5 or 6 technicians, electricians who were reporting to me at that time. So one of the responsibilities I had was that every 2 weeks, I had to take the roster of people working for me to the executive engineer's office headquarters, which was quite a ways away into a big city nearby, and present the names and collect their wages. Of course, these are all cash. Nothing was, there were no checks. There's no direct deposit in those days. So I went in first time with my list, and there, of course, the other engineers came from other villages. Now the old guy, he looks at me and he says, how many you got? I said, well, I've got 6 people. He says, you mean all 6 working? I said, of course all 6 are working. You mean none extra? I said, what do you mean none extra? Evidently the practice was to add a couple of fictitious names, collect their salaries and pocket them. And that just, I couldn't bear to. This is my first experience there. So, this was really a terrible thing. So I wanted to get out of that. So one of my classmates' uncle was the chief engineer of the utility, state electricity board. So I asked him if he would transfer me to the city, and he transferred me to the technical office, where the superintendent engineer technical office was responsible for designing substations, transmission systems, prepare, tender bids, requirements, technical specifications, to go out for bids for equipment suppliers. So as an engineer at the lowest level, my job was to prepare the technical specs, get them published, get the bids in, and on the day of the sealed bids are to be opened, I'll sit there and start announcing, what company had quoted what terms of conditions and what price and things like that. But then soon I found out that the sales reps wanted the charts prepared by this analysis, and they're willing to pay the engineers something under the table to get a copy of it. Which again, I couldn't go on, refused it. But the other issue was this: rather than analysis being done at the junior engineer level, where the basic bids and the equipment is evaluated, the actual selection would come from the top down, from the executive engineer, sorting engineer, telling me which company I should be recommending for the bid. So you can see what was going on over there. So I said, well, this is not I want to end up with my career. So this is when I decided to go abroad for further studies. And 1959, I came to the United States, to the University of Illinois, for my master's in engineering. Okay. The other one, then after finishing my master's in 1960, I got a job at Westinghouse Electric Corporation, Buffalo Division, in 1960. So I got there, and 62 and 63, anyway, so as I just started my job with a senior engineer, they had received a big contract for equipment for the largest excavator in the world for open pit mining in Kentucky coal fields. So I started working on it, but then the engineer I was working with, he left Westinghouse, and my manager says, well, this is your baby now. So I got involved on that one. So in 1962, finally, there was commissioning going on in Kentucky, in Louisville area. So my wife had just joined me from India, and just wanted to leave her alone in Buffalo by herself. So I said, well, why don't I just drive down? There's no simple air connection anyway. So we drove down to the Kentucky, Blacksboro, Kentucky, Central City. And I was there for almost 2 weeks of commissioning, getting started 7 in the morning and work 2 and come back at night. And, so when I came back, I had basically worked lots of hours besides just 40 hours a week. So I came up with a complete time card of my hours that I had spent on the project and commissioning. And I told my manager, I said, look, I'll take some of these hours. I won't charge the company. I'll just take equal time off when I personally need it. But then I said, okay, you should at least pay me for 28 hours of overtime for this period. And right away, his question was, well, you drove down to 12 hours. So, and coming back to, you should subtract those hours from your overtime. Driving time should not be charged. So I told him, well, there's no physical way of getting over there. So, and this is part of the work. And I said, I didn't charge full 12 hours of driving. I just charged only 8 hours for those days. Anyway, I questioned his, he was surprised. I said, no, there's no way I'm going to accept that. Oh, this thing is, or the field engineer comes over, he picks you up, you go for breakfast, you blah. I mean, he says, so right away I stopped him. I said, you are questioning my integrity and character. If you don't want to pay, don't want to pay, but don't question my integrity. Don't question my numbers, how I came up, what I put down over there. I said, I'll never tolerate this kind of remarks. So it was interesting that the next day he came back, he talked to the division manager, he told me, well, sorry, I shouldn't have, questioned you those hours. And yes, you cannot subtract driving hours from your overtime hours. And he decided to go ahead and pay me for my overtime that I needed it. But the question really was, so I told him, I said, look, as a big manager, big boss, you didn't have to even come and apologize. But I appreciate, I just basically respect you a lot more now because you really did come back and, things got straightened out. The other thing happened in 1972 was we were in the systems division where we were designing large systems for steel mills, paper mills, and there one of the departments, one of the sections was in charge of automatic warehousing. And what Westinghouse people had come up with computer systems, they could basically be computer programs and computers to basically build so that instead of sending people to pick up stuff from the warehouses, you could have these little tracks and like almost, this is before robots time, pick up the items from the racks. So they have to be like, so anyway, these projects, since Westinghouse didn't build everything, required a lot of subcontractors. And suddenly one morning I go to work and I find out that right in the next department, evidently the security of the Westinghouse, security, local security, came over and took one of those project managers. I told him to clean up his desk and escorted him out of the plant. Evidently, he had accepted some bribes from some of the subcontractors to give them the business, something like that. And then the ruling came from all the way from the headquarters of Westinghouse that next time, if something like is done, not only the person, not the manager, but even the division manager would be fired. So this is how hard it was. In other words, this is again the compromising ethics. Then in University of Buffalo, you'd think, well, what kind of ethics can you have a problem? One of the courses I taught was fundamental electrical engineering for non-majors. So we had electrical, not electrical, but mechanical, civil, chemical, aerospace, all these engineers, students who would take this course on electrical engineering. So I would have more than a couple of hundred students in the class. And this course was shared by 3 professors based on their own expertise. So I had 1/3 of the course, and the other professor had that. So the question was, so the exam had to be held for each section of each part of the course in class. And of course, the class, it's a big classroom, students sitting next to each other. So to avoid any conflict, any ethical conflicts, I used to actually design 3 sets of exams. Questions would look the same, but answers would be different. Half of would be multiple choice, half of would be to work out the solution to the problems. And I would have, of course, 2 or 3 TAs who would monitor and ask the students to put their ID cards out. And so what happens is I would ask the students not only their name, but also their date of birth on the answer papers. And there were 3 different versions given. So I told the TAs, my teaching assistants, to grade the multiple choice part. And I said, give me the other detailed solution of the questions, and I'll grade those. So one of the TAs came back and brought 2 papers to me. And he said, sir, these 2 papers seem to have identical answers for all the multiple choice. Not only that, he says in the B part of the test, it looks like the handwriting seems to be the same on the both papers. So I graded the rest of the papers. I put them outside the office for the students to pick them up. So then this one student came over and he said, well, I didn't see my paper graded. So I said, oh, what's your name? I said, oh, this is your paper? Yeah. I said, by the way, do you know this guy, this other student name? First he says he didn't seem to know. Then I said, how come? He says, both papers are almost identical. He said, oh, no, I know I said, unless I talk to him, I cannot grade your things. So he basically brought the other students. And of course, right in the first class, when I starting the semester or in my course, I used to give a 1-sheet detail of what the course content was and what the academic honesty policy of the university was. It's all written out in detail so that they could basically, they knew what was going on. And the basic policy of the university was that if you got found caught cheating, you will be basically, thrown out of the university. You will have to just suspend it from the university. So the question was, these 2 so happened that both of these students were foreign students from a far off land. So I talked to the chair of the department. I said, look, this is what it is. Policy says that, they both should be suspended. And the chairman said, look, these are young boys. Their parents, we don't know how hard they work. They send them all the way to America to get educated. If you throw them suspending that, think of the parents, what's going to go through it. He said, let's do it this way. Rather than take the issue any further, let's give them F to both of them and have them repeat the course and give them a good, warning that this is not tolerated. And that's how we basically are around it. So these are some of my own personal, experiences of, getting into ethical dilemma or situations. Now let's look at some of the engineers' code of ethics. National Society of Professional Engineers has their own code of ethics. First section on fundamental canons lists 6 specific codes of conduct for the engineers. The second section on rules of practice provides detailed instructions for the first 5 canons. 9 specific duties with details are listed in the third section on professional obligations. As quoted below, except the red underlined text of suggested amendments. One says, engineers shall be guided in all their relations by the highest standards of honesty and integrity. Engineers at all times strive to serve the public interest. So I'm saying that this is where they need to amend this and say, and not participate in the design and development of weapons of mass destruction. Engineers avoid all conduct or practice that deceive the public, including unethical compromises with employers and or politicians. I think this needs to be added. Number 4, engineers shall not disclose without consent confidential information concerning the business affairs or technical process of any present or former client, employer, or public body on which they serve. Engineers shall not be influenced in their professional duties by conflicting interests. Engineers shall not attempt to obtain employment, advancement, or professional engagement by untruthfully criticizing other engineers or by other improper or questionable methods. Engineers shall not attempt to injure maliciously or falsely, directly or indirectly, the professional reputation, prospects, practice, employment of other engineers. Engineers who believe others are guilty of unethical, illegal practice shall present such information to the proper authorities for action. Engineers shall accept personal responsibility for their professional activities, provided, however, that engineers may seek indemnification for services arising out of their practice or other than gross negligence, but the engineer's interests cannot otherwise be protected. Engineers shall give credit for engineering work to those to whom credit is due and recognize the propriety interests of others. Again, I think we should really add this. Engineers shall only use biodegradable and recycled materials in the design of products, processes, and systems to preserve our planet for future generations. I think this needs to be added. Engineers shall use the maximization of life cycle energy efficiency and minimization of thermal dissipation and pollution as the main design criteria rather than first cost or near-term profits in the development and design of products, processes, and systems. Then the IEEE Code of Ethics. I've got some of them here. To accept responsibility in making decisions consistent with the safety, health, and welfare of the public, and to disclose promptly factors that might endanger the public or the environment. Here again, I would like them to add, and not participate in the design and development of weapons of mass destruction. And to only use biodegradable and or recycled materials in the design products, processes, and systems to preserve our planet for future generations. To use maximization of life cycle energy efficiency and reduction of pollution as the main design criteria, rather than first cost or near-term profits in the development and design of products, processes, and systems. Similar codes of ethics have been adopted by other engineering organizations in the US, such as those who are members of the American Social Engineering Societies as listed below. So there are a bunch of, each society, organization of engineers has their own ethical codes. Regularly, American Institute of Mining, Metallurgical, and Petroleum Engineers, Society of American Military Engineers, and Society of Women Engineers publish no code of ethics for their members at their respective websites. Interestingly, according to the Principles of Professional Conduct of American Nuclear Society, we hold paramount the safety, health, and welfare of the public and fellow workers, work to protect the environment, and strive to comply with principles of sustainable development in the performance of professional duties. Well, the question arises as to whether nuclear engineers developing nuclear bombs or other weapons of mass destruction projects do belong to NS or not. If they do, aren't they violating this specific code of conduct? Actually, just saw recently IEEE, one of the IEEE's papers, magazines, newsletter, showed this. Somebody has designed this robot that can carry guns, carrying guns in the field. Now, the code of ethics in Canada is very, very important. It's very interesting. On August 29, 1907, the partly constructed cantilever bridge collapsed into the St. Lawrence River killing 75 to 86 workers who were present. Failure took no more than 15 seconds. Event leading up to the failure began many years earlier. This slide is from the presentation Dr. Kristen Human, School of Engineering Applied Science at Buffalo, presented last year. So they call the calling of the engineer. Calling for an engineer is an oath. In 1916, 13 more workers lost their lives during construction of replacement bridge. Effort to reform the profession moved forward through two initiatives. Looking to government licensure of engineers, the formulation of a pledge along the lines of the Hippocratic Oath. First calling engineer or iron ring ceremony held at the University of Toronto in 1925. As a matter of fact, last year in 2020, when I was invited to present this 2020 End of the Year Award, this presentation was made there, and I was to join the calling of the engineer, and I got the iron ring that I wear now as a member of this. The Order of the Engineer, 1953, initial correspondence between officers of the Ohio Society of Professional Engineers and Canadian counterparts. In 1966, Ohio engineers began to explore Order of the Engineer. June 4th, 1970, first steel ring ceremony at Fenn College. By the way, this steel ring initially was made from the from the bridge that collapsed, the steel that came from the collapsed bridge. June 4th, 1970, first steel ring ceremony at Fenn College of Engineering of Cleveland State University. Approximately 170 seniors and faculty participated. This was last year, of course, 50th birthday. Since then, the movement has spread rapidly throughout the United States. Members are inducted by links which are chartered through the National Office of Order of the Engineer. And the UB's link is at 233. Again, this is her slide. What is the obligation? I'm an engineer. In my profession, I take deep pride. Do I owe solemn obligations? As an engineer, I pledge to practice with integrity and fair dealing, tolerance and respect, and to uphold devotion to the standards and the dignity of my profession. Conscious always that my skill carries with it the obligation to serve humanity by making the best use of the earth's precious wealth. As an engineer, I shall participate in none but honest enterprises. When needed, my skill and knowledge shall be given without reservation for the public good. In the performance of duty and fidelity to my profession, I shall give my utmost. So this is the oath that these engineers now take in Canada or in the United States, wherever they offer this ring. Engineering profession in Canada is regulated in each of its provinces and territories by the respective regulatory entities. Engineers Canada is an umbrella organization of these provincial and territorial engineering regulatory bodies. While the NSPE in the United States has a top-down structure with chapters in each of the states, the Canadian organization has a bottom-up structure as an associate of individual regulatory bodies of provinces and territories. Though each of the provincial engineering regulating bodies have their own respective code of ethics, the Engineers Canada also has a published code of ethics with the purpose of establishing one code of ethics for all engineering license holders, will promote a common standard across the country, enhancing the safety of the public and providing a unifying state with the high standard expected in the profession. The key considerations of code of ethics are reproduced for a quick reference. Number 4, all registrants shall conduct themselves with integrity and honorable and ethical manner. All registrants shall uphold the values of truth, honesty, and trustworthiness, and safeguard human life and welfare and the environment. In keeping with these basic tenets, registrants shall hold paramount the safety, health, and welfare of the public and the protection of the environment, and promote health and safety within the workplace. offer services, advise, or undertake engineering assignments only in areas of their competence and practice in a careful and diligent manner. Uphold and enhance the honor and dignity of the profession. This is the British spelling of honor. Act as faithful agents of their clients and employers. Maintain confidentiality and avoid conflicts of interest. But where such conflict arises, fully disclose the circumstances without delay to the employer or client. Keep themselves informed in order to maintain their competence and advance their knowledge in the field within which they practice. The code ethics conduct themselves with equity, fairness, courtesy, and good faith towards clients, colleagues, and others. Give credit where it is due and accept as well as give honest and fair professional criticism. Present clearly to employers and clients the consequences of engineering if engineering decisions or judgment are overvalued or disregarded. This is very important. I think we have to be fully responsible for that. Report to their association or other appropriate agencies any illegal, unethical engineering decisions or practices by engineers or others. Be aware of and ensure that clients and employers are made aware of societal and environmental consequences of action or projects and endeavor to interpret engineering issues to the public in an objective and truthful manner, and treat equitably and promote the equitable treatment of all clients, colleagues, and co-workers in accordance with applicable legislation. In addition to this, a set of guidelines outline the following 5 fundamental principles also established. Protect the public and the environment, faithful agent of clients and employers, competence and knowledge, fairness and integrity in the workplace, professional accountability and leadership. Now, even in China, the ethical attitude towards engineering technology based on traditional cultural background emphasizes the ideas of harmony and the Tao or natural way of things. Engineering as a profession has been recognized only recently since the Declaration of PRC in 1949. To transform and modernize the residual feudal society and to industrially develop the nation, government initially emphasized science, technology, and engineering. Recent engineering ethics in China has been a subject of considerable debate between traditionalism and modernism. So after studying 15 different institutions, Chinese registered engineers and 45 constitutions of engineering communities, Ceu and Ceu found that engineers today stress doing engineering well rather than doing good engineering. That is, engineers tended to emphasize simply technical competence without serious consideration whether the project in which they were involved were really good projects. Most ethical guidance for engineers is assumed to derive from the public, not from within the professional engineering community. Distinctive professional codes for engineers have not yet been formulated, and the professionalizing process is still going on. And no exception here is the Declaration of Engineering Ethics in 2004. But there also exists some gaps between the development of Chinese engineering and contemporary requirements for ethical consciousness and imagination. In response, several polytechnic universities are now attempting to set up engineering ethic curricula to promote responsible conduct among engineers and polytechnic students. How about EU countries in Europe? European Federation of National Engineering Association based in Brussels, Belgium, an umbrella organization of 3.5 to 4 million engineers and scientists from 32 member nations of the European Union, of the EU. Some 350 professional associations of engineers and scientists belong to this FEANI. These member organizations and their rank and file members commit themselves to the following ethical principles of code of ethics. Ethical principle: the decisions and actions of engineers have a large impact on the environment, on society. The engineering profession thus has an obligation to ensure that it works in the public interest and with regard for health, safety, and sustainability. The framework statement is National Association of Engineers and FEANI, with regard to EURNG registrants, have codes of conduct which have much in common with, which have the intent of implementing the above ethical principle. As a result of this convergence, the European engineering profession as a whole can make a universal statement regarding the conduct of professional engineers. Engineers have a personal obligation to act with integrity, in public interest, and to exercise all reasonable skill and carrying out their work. In summary, as we review the Code of Ethics for Engineers, we find that common to all disciplines and regions of the world, first and foremost among them is the commitment to safety, health, and welfare of the public with protection of the environment. Yet we find that thousands of products, processes, and systems are being designed by engineers around the world which do not live up to this commitment. This is what I want to now talk about, the 3 Ps. Technology innovation of engineers influences how people live, what happens to the planet, and how the economic engines operate. In other words, what we do as engineers have profound influence on people's life, on the planet's environment, and profits of corporations. Let us take a look in the review mirror at the history of technological developments since the dawn of the 20th century. With lighting of the Chicago's World's Fair in 1893 and completion of the first long-distance transmission line with hydroelectric power from the mighty Niagara Falls to the city of Buffalo in November 1896, the age of electricity began in the USA. Electricity, power tools, and automation in factories began the industrial age at the end of Great Depression in the last century. Industrial productivity, measured in terms of output per unit of labor, made major gains. This brought about the economic prosperity in the Western world, created a large middle class of consumers during the following decades of the 40s and the 50s. After the Second World War, we entered the atomic age, which gave us the technology to build nuclear power plants for production of the so-called cheap electricity during the decades of 50s and 60s to keep running the engines of economy. Challenge to land man on the moon and bring him back safely started the decade of the space age. It accelerated developments in semiconductor electronics from tyrosine transistors to integrated circuits and microprocessors. Advanced microelectronics, computers, and internet brought the information age, which accelerated productivity gains in the white-collar workers of the industry and the dot-com revolution during the last decade of the past century. Globalization of the economies and simultaneous increase in standards of living throughout the world, but exponentially growing population have started to increase pressures on energy demand for both transportation and electricity. As we have embarked upon this new century and the third millennium, we have now entered the energy age. Engineers' challenge is to minimize the amount of energy consumed per unit per function performed for every piece of equipment we use. For exponentially growing global population while minimizing harmful effects on the planet and creating economic opportunities with fairness and equity for all. Here's what the population of the world has been going on. Now for 1 billion, we'll approach actually by 2024 is 8 billion or so. Right now it's around a little over 7 billion. While technical contribution engineers have brought many conveniences for better life for this exponentially growing population, they're also responsible for major occupational disruptions for most. This is where the typical population concentrations are in the world. If you look at the 1900 to 1990, the 20th century, the US population kept increasing, but what happened? The farm population started going down because the productivity in the farms, the technology that engineers developed, helped them improve the productivity of the farmers. So it went from 40% population down to a couple of percent. As mega farms drastically improved the agricultural productivity, it reduced employment on the farm. In spite of growing demand to keep up the growing population, the farm employment continues to decline during the 20th century. Well, this is what happened to the number of hours worked. Like, there was 70 hours people worked in 1825, but then the hours kept coming down. Then we had, of course, the Depression. Then they went up with the Second World War and started coming down. Basically, we ended around typically, 40 hours a week was considered typical. At the same time, the real wages were increasing until some 1975, 1972, somewhere like that, about 50 years ago, when suddenly the things changed. As technology brought gains in labor productivity, leisure hours increased, creating new leisure time industries such as movies, TVs, and other recreations. Also, it brought in more women into workforce. So it changed the structure. The women started going more and more into the workforce as the time went by from 1900 to 2000. We went up to 60%. And this chart basically shows, household work 2 to 3 hours and, 1 hour per day, 33% of people. So you can see that how, where 87% of the women were busy just doing housework, it's basically, come down much more. However, US manufacturing productivity and output have risen while employment has declined. This is a problem that we are facing right now. And while the productivity increased, output kept increasing, but the employment kept going down. So we are 66.7% in 2010 compared to 1987. How drastically, people have lost their jobs. And math jobs, also by education level, when you look at it, it's, basically people who had high school, just high school, they've lost, they have come down quite a bit, their job. But the higher degrees, advanced degrees, have basically maintained, their levels. But, high schools, dropouts have really lost out. Okay. Bachelor's degrees have kept up. So those have been saved, but so it's very, the growth in robots intensity for all industries. Suddenly, is what's happening. Robot intensity is right. But again, who designed robots? As engineers. So we have become a participant. And, the thing is this, increasing the productivity, giving tools and equipment to increase the productivity of a laborer is, very nice. It's good because that he gets paid more, he gets his life, his living standard improves. But when you start designing robots and systems to replace humans, then what are you doing? You're taking their jobs away. So there's a limit as to how far we can push this robot business. It's one of my other subject that I talk about is economic measurement of economic power. Economic power is a power is always product of two variables, voltage and current, speed and torque. So in here it is economic potential and economic flow. And economic potential is education, and economic flow is cash flow. So only humans have that. Robots can replace humans, but they have no economic power. They have no cash flow. They do not buy anything. So the question really is how far ethically we should be responsible in promoting these robotic devices that replace humans. Somebody recently sent me a little cartoon. This one guy says, I'm really concerned about artificial intelligence, increased artificial intelligence. And the guy responds, well, not so much. I'm more concerned about loss of real intelligence, decrease in real intelligence. And that's what we have to be careful. Okay, I'm going to go to the next slide. Okay, everybody ready so far? Any comments, any questions? Okay, let's look at the planet. Praise be to the Lord who created this colorful world. There are white pigeons and brown pigeons and gray pigeons and black pigeons. There are white swans and black swans. There are white puppies and black puppies. There are white horses, white monkeys, black monkeys, brown monkeys, flowers, and parrots of all colors. Treat the earth well. We have not inherited the earth from our ancestors. We have borrowed it from our children. Okay, climate change. This is a 2014 report of the United Nations. The latest assessment by the UNEP and World Meteorological Organization supported intergovernmental panel on climate change, released in late 2014, concluded that climate change is already affecting many communities with far greater impact to come. Mean average surface temperature rose by 0.89 degrees C from 1900 to 2012, and global average temperature is still rising 0.3 degrees, 0.7 degrees, 16. Actually, it's going to go higher than that, according to the latest report now. The conference is going on in Glasgow. This changing climate will affect sustainable development in many different ways, from impacts on economic growth to food security. Actually, just recently, the ABC, they showed what was going on in Madagascar, where although the climate change has totally ruined their farm, their food supplies, and the World Food Program started to do something about it to help them. Shifting weather patterns, for example, threaten food production. Through increased unpredictably rainfall, rising sea levels will have a range of impacts on coastal environments and infrastructure. And extreme weather events predicted to become more frequent, severe, and cause devastation. And they are doing it already. Here is some chart showing the global land and ocean temperatures in July from 1880 to 2019. Look at that, how far it's gone. So with all of this going on, the last administration, in their wisdom, decided to pull out of the Paris Accord on climate change. Here is what's going on in terms of change in mean sea level, how the sea level keeps increasing. So what happened to the coastal communities? UNEP assists governments, businesses, and individuals to reduce emissions in an effort to minimize the pace and scale of climate change, and assist those nations and communities most likely to be affected to become more resilient to changing conditions. So there's a serious problem. The way you have to look at it is that we engineers were responsible for advancing the civilization of the last couple of hundred years to what we have today. But at the same time, we're also fully responsible for all the harmful effects that have come out of it for the planet and for the people. In 2018, the world received a stark wake-up call when the Intergovernmental Panel on Climate Change released its special report on the impact of global warming of 1.5 degrees C. The panel research told us that time is running out to minimize extreme weather events, species loss, water scarcity, and many other climate impacts that endanger lives, economies, and livelihoods. This is a message from the Secretary General of the United Nations. Well, let's take a look at profits. See, we look at the people, what has happened to people in terms of their jobs, what technology has done to their job, to the employment level, to the employment, right? Then we also saw what we have done to the planet. But let's look at the profit. In classic capitalism, early to mid 20th century, commercial corporations were to serve the needs of their consumers at fair market prices with social responsibility. Employees were considered assets and were paid fair wages for a fair day's effort. Capital, equity, and borrowed was considered one of the factors of production. Fair prices were set through elasticity in supply and demand of the classic free market. Top exit compensations were no more than 10 to 15 times average employee wages. When I started my job at Westinghouse in 1960, the CEO of Westinghouse salary was no more than 10 times the basic average factory worker. Financial institutions like banks and savings and loans were well regulated. Well, what happened? When the actor Ronald Reagan became the president, what did he do? He deregulated savings and loans, gave the blank check to merchant and farmer so that they can be too big to fail. Energy sector monopolies were regulated through Public Service Commission. Well, and they were deregulated during the Reagan administration. This economic framework created equitable distribution of wealth for factory workers and a large middle class in North America, envy of the world. The world envied us. We're the largest group of large percent of population considered to be middle class. These are two good examples of classic capitalism. Henry Ford and George Westinghouse were the champions of classic capitalism and responsible for the Industrial Revolution through the auto and electricity industries. Fundamentally, Ford believed that high wages help business in the long run by enhancing workers' ability to consume. In later years, he insisted that the real progress of our company dates 1914. Because with the age increase, we increase the buying power of our own people, and they increase the buying power of other people, and so on and on. It is this thought of enlarging buying power by paying high wages and selling at low prices behind the prosperity of this country. So when he said buying power, he actually means economic power, right? That's what was there. As a matter, what happened was this, that Henry Ford, of course, he started the automobile business, and he was on a vacation someplace, nice, and he came to a thought. He says, the people who make these automobiles for the rich people, I said, how can I make them, they can afford to buy their own product? Because these people are making cars, but not for them, they couldn't afford them. So he came back and he told his finance, CEO, the controller. He says, how about doubling the wages? And, he said, controller said, oh, no, it's going to cost you $7 million. He said, no, it's worth it. He said, then he explained, this is what's going to happen. And this is really what happened. So The People's Tycoon, Henry Ford and the American Century, it's a beautiful book to read. And here's George Westinghouse. My aim is to give as many persons as possible opportunity and money by their own effort. And this has been the reason why I have tried to build up corporations which are large employers of labor and to pay living wages, larger even than those manufacturing pays or than those labor market constitutes. George Westinghouse. This is Empires of Light. It's a very interesting book about between Edison and Tesla and George Westinghouse. But neo-capitalism, 1972. Mr. has changed to serve the greed of the top executives and bankers. Consumers are nuisance to contend with, and employees are considered liabilities, paid below party levels. Anytime a company issues a statement that they are laying off some workers, their stock prices go up. Prices are set through control of supply in a manipulated market. Before the airlines were deregulated by Reagan administration, there were dozens of airlines, okay? But they allowed them to merge now, so they became too big to fail. Now we have what? 3 or 4 airlines, that's it. So maybe 5, okay. So, and then basically, so see, for a free market capitalism, you keep talking about market, free market, free market. There is no free market. Free market requires elasticity in supply and demand. So that when there's a more demand, the price of the commodities go down, and when the price goes down, there's more consumption. But the suppliers want to make more money, so these two curves cross, and that's when you come up with a market price. But when you don't have a elastic, when you have a plastic market, where the supply curve is plastic, it's not elastic, then what happens? This is what happened. And capital, equity borrowed is considered the only factor of production. Top executive compensations have risen to more than 300,000 times lower level employees' wages. Find out what Jeff Bezos gets and what Elon Musk gets. For instance, like, as a matter of fact, Elon Musk, you have heard about it, that he just sent a tweet or something asking people that he should sell his, stock option that he bought the Tesla stocks, because he's going to end up with some $12 billion tax bill. Prices like banks and savings loans have been deregulated, creating oligopolies. Energy sector monopolies have been deregulated with no one to watch. This economic framework created ideal environment for mafia types to infiltrate the corporate boardrooms, halls of Congress, and the benches of the Supreme Court for flow of wealth from low-wage earners to the top executives, destroying the middle class in the USA and spreading in the far corners of the world. This is what it looks like today. The result, here's from one of the Oxfam reports. Almost half of the world's wealth is now owned by just 1% of the population. The wealth of the 1% richest people in the world amounts to $110 trillion. That's 65 times the total wealth of the bottom half of the world's population. The bottom half of the world's population owns the same as the richest 85 people in the world. The founders of the Walton family is the richest family in the United States. But their philanthropic spending is less than 0.1%. 7 out of 10 people live in countries where economic inequality has increased in the last 30 years. The richest 1% increased their share of income in 24 or 26 countries for which we have the data between 1980 and 2012. In the US, the wealthiest 1% captured 95% of post-financial crisis growth since 2009, while the bottom 90% became poorer. The result is a very nice article in the New York Times on what has happened with the corporate greed. So what is the ethical framework for engineers? With global economies and social media at everyone's fingertips, we are now part of the humanity. Our professional skill affects all and everyone around the world. While this is a major responsibility, it's also a unique opportunity to make the world a better place for all. We need an ethical framework to perform our professional responsibilities. Professional associate societies do provide us with a set of code of ethics, as we reviewed earlier. Question to ask ourselves as we work on a project. What effect it will have on the planet's environment and habitations? What effect it will have on humanity? What effect it will have on my country, its people, and its resources? What effect it will have on my neighborhood, my friends, and my family? What effect it will have on my profession? So these are the basic questions we must ask ourselves whenever a project is handed to us. How am I going to design this project or process or the product? What effect it's going to have? Then we'll come to the right conclusion. We'll come to the right design. What effect it will have on my career? So social responsibility, as individuals, families, community, nations, we have invested with certain powers These powers fall into categories of physical power, intellectual power, spiritual power. At the individual level, physical power comes from the body, often enhanced with personal tools and weapons, as well as monetary wealth. The intellectual power comes from the mind, often enhanced with technology, as well as socio-political status. The spiritual power comes from a soul, often enhanced with religion, religious convictions. Similarly, at the national level, physical power is measured by military and economic strength. The intellectual power comes from the institutions of education, research, and technology. The spiritual power comes from the moral and ethical values of its people. Within civilized societies, we as individuals, families, and communities claim the rights to freely exercise these powers to protect and advance our own self-interest or those of our friends and allies. Same appears to be also true for government in a civilized international community of nations. However, the rights to freely exercise these powers without responsibilities and respect for others' rights result in conflicts at the boundary where it begins to infringe on the rights of others. In the absence of any ethical or moral framework to constrain the rights of individuals and nations at these boundaries from exercising powers, a framework of rule of law is needed to protect weaker individuals, families, communities, and nations from abuse of power by the stronger ones. Unless we as individuals, families, community, government respect others' rights to pursue their own self-interest, we cannot claim to be a civilized society. That is, there are 4 R's of civilized societies: rights, responsibilities, respect for others' rights, and rules of law. Whether it's the government's right to block the use of human embryos for stem cell research, or a self-proclaimed guardian of the unborn's right to assassinate medical practitioners performing abortions, or the newspaper's right to publish derogatory cartoons and syndicated columns attacking religions and the holy prophet, or the nation's right to use their military might to change regimes of other nations or to destroy neighboring countries' infrastructure to gain rid of a couple of soldiers, these rights must be exercised with responsibilities, with respect to others' rights, and within the frame of rules of law, if we are to live a world more peaceful for our children and grandchildren than one we inherited from our parents and grandparents. Social responsibility, basically, you can look at them in the globe chart. There are moral, ethical, and legal sphere that we can work with. But zones of average society with secular democracies. But then there are legal, not moral, ethical. So we set up our own, which legally is allowed, even though it's not moral or ethical. So we can do it because we passed the laws to get it done that way. Then there are society dictatorships, where legal is much smaller than what could be moral, ethical. Let me go back. Okay, but it's not considered legal because the dictatorship cuts you down into the legal sphere, much smaller than what moral, ethical values would allow you to do. Then zone operation societies with religion, race-based apartheid governments. So then you have 2 separate, legal but not ethical, moral. So you end up with a small moral, ethical, and legal zone, much, much smaller. So what do we do now? Let's take a look at social responsibility again. Nature, God has endowed us with 3 great gifts: lifespan, time in this world, material resources, wealth, skills, and knowledge. These gifts are handed out in different quantities to each one of us. So we're not responsible for how much of each of these we get, but we are accountable for how we spend them in service to humanity. We depend upon time and effort of thousands of individuals to satisfy our daily needs. You go to the supermarket, it took thousands of people to grow those foods and grow move those, big trucks, bring this stuff to the supermarket, somebody to put them there, somebody vegan, right? 1,000 people involved. Also, 1,000 individuals depend upon our time and effort to satisfy their needs. So we don't work for a living. We work to serve those who need our time and effort with the knowledge and skills we have to offer. So don't look at the job as an earning a living. That's the biggest concept we have to accept. There's a prescribed just compensation for these services to the society in monetary terms. When the real compensation is less than this, the difference becomes our charitable contribution to the society, for which we get compensated other forms in this life or in the hereafter. Don't worry about it. Do what is right, what the job requires, what our responsibility is. Don't worry about it. I know I was Westinghouse. I did some, entire experience in my early years over there. I went to talk to one of the engineers in the motor department. I needed some data. I wanted some help from him. His response was, "Well, I do as I'm paid. That's all he's going to do." Not that what his really job function was. This is a wrong idea. I think we should really, what you have to look at is this, that even if your real compensation is not what you think is just, don't worry about it. God is watching. You are going to get some other ways rewarded for it. On the other hand, if we are overcompensated or overcompensate ourselves, the difference becomes a debt to the society, not maybe in this world or in the hereafter. Not you, your children and grandchildren probably will pay for it. Now let's talk about an engineer and the brilliance of a mind. Diamond is forever, so is an engineer. Brilliance of diamond is defined by 4 C's. Color. This brown diamond ranges from icy winter white to warm summer whites. It's graded on a scale from D colorless to Z established by the Geological Society of America. Clarity. This brown refers to inclusions in a diamond, which is ranked on a scale of perfection ranging from F flawless to I included by GIA. Carat weight. With density consistent among all diamonds, the physical size of a diamond is expressed by its weight in carats. A carat is a unit measurement weight equivalent to 200 milligrams. Cut. Based on natural laws of physics, light entering the stone is subjected to reflections from one mirror light facet cut and polished with precision to another and dispersed within the diamond to maximize its light output to the top of this stone. How about the human? The brilliance of human mind depends on 4 N's, INs. Instinct. Besides being an inborn, a tendency to action common to a given biological species, it also refers to a natural intuitive power of the human mind. We have instincts to react, to accept something. Inspiration. It is considered mostly a divine influence directly exerted upon the mind of a person on an instantaneous basis. For example, prophets of God, they were inspired by divine authority. Intelligence is the capacity of reasoning, understanding in similar forms of mental activity measured by IQ tests. So these are very similar to the 3 C's of a diamond. Then comes indoctrination. It's the same thing like a cut. It's acquired property, particularly the development and training the mind in doctrines, principles, and ideologies. So this is how we were mentored, how we were raised, what our influences we had from our faculty, from our mothers, parents. The mind receives intelligence from Aql Awwal, the source of our knowledge. It gives it the brilliance as described in the following translation, 2 original Arabic verses as listed here. Al-Aql, the mind, in human is the loftiest jewel, glistening with brilliance in his soul. Al-Aql, the mind, is human, is in need of light, which radiates from a higher luminous stage. So all knowledge God has created, God Aql is a source of intelligence. That's where we get it from. We don't create anything. His Holy Dr. Safiuddin book, that's where it comes from. In addition to the mind, humans also have a soul. which acts like a filter through which the light of knowledge passes and then reflects from the mind. The fifth in is the integrity of character, depend on this filter. That's our soul that dictates the integrity of our character. Al-aql level is superior to everything if it is bi-aql salim, that is not overwhelmed by obstruction of our soul. If caprice overpowers, caprice will ride upon it. And all the stumble is results and consequences. Like the color which taints the dazzling light. And for the viewer, the true color of each colored article becomes changed. Aql is said by numerous perils, haughtiness, tyranny, and domination. Basically, what the author is saying, poet is saying, is that if you put a white light and a clear lens on a diamond will look white and clear. But if you change the filter to a green piece of glass or green, the diamond will look green. So basically, our soul acts like that filter. So what about intelligence? Okay. The human mind has instinct, inspiration, intelligence, and indoctrination. Or the soul directs the mind, and mind directs the body. In humans. In animals, instinct, intelligence, indoctrination. They don't get inspirations, but they do have instincts, they do have intelligence, they have indoctrination. Recently, I just saw a little video somebody showing this fish way down deep in the ocean and how completely geometrical design of the ground first, it was forming it. So they have intelligence, they do that. We know about it, all kinds of animals we have seen. So nature directs them, and the body, the animals work like that. How about the robot? Robots have intelligence and indoctrination. And it's a system. And that's mechanisms work on it. So what we're saying is this, that when we carry on any work or any organization, there should be a clear-cut mission statement. That only is going to direct how we work, how we perform, how the business operates. So the basic mission statement consists of these answers to these following questions. Whose needs are to be satisfied? What needs are to be satisfied? How the product services would be delivered to those needs, to those in need? What physical infrastructures would be used to satisfy those needs? What constraints would govern the mission? The statement has to be focused yet broad enough to adapt to a dynamic market. And it's a statement, not statements. It's only one sentence that answers all these 5 questions. For example, a social responsibility mission statement may read as follows. To satisfy the needs of national and international clients for high quality and reliable engineering products and services, for the clients in the aerospace, medical, automotive, railway sectors, through a network of sales and service facilities with our associates at competitive prices, while maximizing return on investments for all stakeholders and contributing to the economic growth of the region, while upholding the human values in the pursuit of goal numbers 3, 7, 8, 9, 12, 17 of the 17 Sustainable Development Goals set by the United Nations. What about me as an engineer? To satisfy the needs of my employer organization for high quality services in the technology areas of blank, 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 through my time and effort at a fair monetary and non-monetary compensation, while fulfilling my duties to my family, my community, and the nation with honesty and integrity. So this would be an engineer's mission statement of life. In a technologically driven economy with publicly traded multinational corporations with monopolistic powers, we must redefine the factors of production as labor, material, energy, finance, technology, management, environment, and public infrastructure. So suppliers of these should be part of the board of directors, not just stockholders. So to minimize the Walmart effect, you may have read about it. Board of directors should consist of all of these people because they can create, the thing is this, if somebody starts up, for example, if Amazon wants to set up a big warehouse someplace, well, these local public will have to set up access roads, all the other things that come with it. So, and what happened is actually this happened in New Jersey. I think one of the one of the pharmaceutical companies took away the land because they want to build a big plant or something. So all these individual people gave up their homes and everything because of, there's some clause which allows that for public good, they can take away your private property. But after all of that done, the plant was never built. Depending upon the size of the corporation, the board of directors should include the following representatives on the order of priority: investors, employees, technologists, energy suppliers, material suppliers, and local government. Now let's look at some case studies quickly. There's a recent news item that Saudi Business Group has offered to build a coal-fired power plant costing around $4 billion in the newly created state of Telangana. What are the social responsibility issues? Should an engineer given the assignment design this plant? This Glasgow conference just talk about to get rid of coal for good from the world. But United States, India, and China have not signed on to it. But Canada, just within, I think, within last few years, there are no more coal-fired power plants in Canada. They got rid of them all. They shut them all down. So this is creating cleaner air in Ontario. You look at that, you'll find it. How energy is fleecing Ontario electricity consumers. These are very two nice links to look at what Canada is doing. Here's, Eggland West and top, these people sell eggs in styrofoam cartons. Styrofoam has many benefits, including insulating quality that helps keep food warm. Also lightweight, has high durability strength, making it an excellent packaging material. Nevertheless, polystyrene, styrofoam, is made from petroleum. In its production process, a carcinogenic chemical known as benzene is used. Due to the presence of benzene in styrofoam, it is inevitable that food in direct contact with styrofoam food packaging would be affected. This has been one of the main reasons why over 20 cities in the United States have banned this use of styrofoam. But who designed the package? Some engineer designed it. Who designed the styrofoam process? Some engineer did it. Moreover, styrofoam is hardly biodegradable. In the absence of suitable solvent, styrofoam can last almost forever. Here is Tide. Pods are not only filled with a super concentrated detergent, they also contain a stain remover and a brightener. These laundry packs can be used in all machine types, even if you use an Ieee washer, high efficiency washer, because they are pre-measured, all of that. But what happens? They look like candy. So laundry sickens thousands of kids a year. Who designed it? Some engineer designed it. Because industrial electronics at the end of useful life. Look at this. They tell you that these fluorescent tubes energy efficient, but they don't last, not even 8 years as they claim. Now what happens to the rest of it? Compact fluorescent lamps and other energy efficient lighting such as linear fluorescent and high intensity discharge lamps, very small amount of mercury, an element essentially, and while these lamps help consumers business cut their lighting energy use, energy cost is important that any product containing mercury be properly managed. At one time I looked into it, I found out that only 2% of the fluorescent bulbs and lights recycle, safely recycle. Use and abuses of drones. Boeing 737 MAX. You all know about it, right? Angle of attack sensors, manufacturer causing to force the nose to the plane down. Crash of 2 aircraft, killing 346 people. Possible cause, design flaws, company culture, poor quality, oversight, society, loss of life, huge economic, professional loss of public. What happened? Well, somebody didn't design it right. How about this? Volkswagen emission scandal. Defeat device installed by Volkswagen in 11 million diesel cars worldwide between 2008 and 2015. Well, who came up with these defeat devices? Some engineer designed it. If engineer had refused to cooperate with the Volkswagen management, this would not have happened. Actual pollutants emitted levels, on average, 4 times those measured in the lab. Tremendous health impact. Okay, ethical issues of just plain wrong, right? So this is, these are the, I'm just picking up some case studies to talk about it. On the bright side, what India has done, they took the plastic bottles, waste plastic, crushed it, and made a road surface out of it. That's done by Tata. What we see from these case studies is that since management financial rewards are based on short-term goals, their focus is short-term profits with no consideration for long-term health of the people or the planet. We engineers have the obligation to focus on long-term health of the people and the planet, so it must resist the pressures of the capitalists and the politicians. Here are some thoughts. It's not the destination, it is the path we take, and how we travel makes us who we are. The strength of a nation doesn't come from its weapons of war. It comes from interior character of its people. In a pot of milk, cream rises to the top, but in a swamp, scum rises to the top. Choose an organization that's pot of milk and not a swamp. Integrity of character is a priceless crystal vase. Even a small hairline flaw renders it worthless. Here is a nice quote from Ralph Waldo Emerson on what success. To laugh often and much, to respect intelligent people and affectionate children, to unappreciate honest critics and endure the betrayal of false friends, to appreciate beauty, to find the best in others, to leave the world a bit better with a healthy child, a garden patch, or redeemed social condition, to know even one life has breath easier because you have lived. This is to have succeeded. These are some of the further reading references. Well, again, thank you for your attention, and I'm ready for any questions you might have.
If anyone has any questions, just go ahead and request to unmute yourself or type them into the chat.
Right, yeah. Okay. Well, this whole thing is being recorded, right?
Yes,
And
it is. It is.
what I can also do is I can basically get a PDF of these slides and, send them to you, and you can maybe post them on your website if people want to go back and refer to them or something like that. We could do that.
Yes, that would work very nicely for us. We will post them publicly, and then also this recording will be available online too.
Yeah. Okay. All right. Again, thank you for your attention, for your time. I hope this was good for you.
Yes, it was very informative. Actually, we have a question from Dave
Sure.
Zabel, who asks, "Will the references to the web pages be accessible from the PDF?" I think that's what will be.
Exactly. Yeah. I think what I will do is I'll give you a PDF file, or PDF print of my slides, so you will have everything from those slides there. Yeah. How many finally attended? May I know?
We had a maximum of 35 participants in the meeting.
Oh, that was good.
Watching that number. So
Okay.
35 out of 46. That's actually pretty good for
That's pretty good.
most
Yeah,
events.
okay.
Usually we get about half of those, half to 60% of those who
Right.
who sign up. Kirk McNamara says in the chat that life cycle analysis can be a good tool to figure out trade-offs.
Right. Right.
I do
Oh,
have a
yeah.
question actually, Doctor.
Yeah.
Is there I know we talked about the benefits to society and a lot of other things that tend to be qualitative.
Yeah.
Is there a quantitative quantitative measure that us as engineers should consider
what?
looking at in terms of how we quantify the benefit of what we're doing?
I think it's, yeah. Yes, it should be able to do it. But however, the problem we basically have is, there are so many projects, so many things going on. How do you quantify it? But I think what basically I'm saying is this, that as an engineer, if somebody gives us a project, first thing we ask is, at the end of the life cycle of this product, what's going to happen to it? Where it's going to end up with? So if we have that in mind, then we can choose the material, we can choose the process to make sure that it's for example, we are going gung-ho on EV, electric vehicles, with all of these battery powered vehicles. Okay, all we have done is shifted the pollution from automobiles to power plants. Okay, second thing is, these batteries cannot be recharged forever. So they only have a life cycle of 5 to 6 years or 5 to 7 years. Then the question is, what happens to the product, the material that is used in manufacturing these batteries after 7 years? How much of that is recyclable? How much of that is going to end up in landfills? So I think this is the whole issue right now, that we are going on gung-ho on Tesla, but the problem really is, unless all power plants get rid of carbon, coal, and coal fuel, or shut them down, we are not helping ourselves. I mean, if you have, just like gas stations, if we had gas stations with solar panel roofs, so we take the solar energy to charge the batteries, and so when a car pulls in, all you do is you swap the battery. You put a charge battery in, and you take out the discharge battery and put in the charging system. So if we had this kind of infrastructure throughout the country, then I can see, yes, there's some advantage, because you're using only solar energy, not getting, the thing is this, I have a complete chart of process of power conversion process. And if you look at from coal or any fossil fuel, the total energy contained in the fossil fuel to the actual energy delivered to the utilization point, it's only 33%. So 67% of the energy ends up in the environment one way or the other. A lot of coal-fired power plant, right? There's so much heat, and CO2 goes out of the power plant chimneys. So I've got a complete chart with showing percent efficiency of each step, each stage of it. So we have to start looking at those things. I'm too old of in my career. I'm not going to get any more new projects, but at least you people, the young generation, now carry it out.
Thank you. We appreciate that
Sure.
insight.
Okay.
Let's see. We're about at 2:52. I'm just gonna go ahead and once again share the information that those of you who are attending and want to receive PDH or Ceu credit will need. So again, for those of you who missed this at the start, attendees to this meeting will receive only PDH or Ceu credit, not both. Here's how to receive that credit. You want to go to the event page, which is the same link you registered at. Scroll down and follow the instructions that are there. You will see the link, and also you'll see the link to the questionnaire, which I would advise you to complete as soon as possible. And then also you'll see an evaluation form, link to an evaluation form. Please download and complete that, and then email that to me, judahrichardson@gmail.com. Please try to do that by midnight on Sunday, because we're trying to get all these together to send to the IEEE on Monday. And then hopefully that will give them enough turnaround time to get those credits back to you by the end of the month. I understand that some people have deadlines by November 30th to get this done. Let me see. There is a okay. There's I'm gonna put these links also in the chat for convenience. They're actually pretty
Log off.
large. So pretty large and pretty complicated, which is why I didn't put them directly in the presentation itself, but there, I've put them in the chat. So just go ahead and complete both of those by this coming Sunday at midnight. Complete the questionnaire, preferably as soon as possible, because that one's super easy. And then the evaluation form, download, complete it, and email it back to me. In the absence of any further questions, I'm going to go ahead and thank Dr. Safiuddin for putting on this wonderful presentation with the view of engineering ethics from multiple perspectives. Really appreciate it. I see from the chat that many of our attendees appreciated it also. And thank you very much for everyone who took time out of their day to attend and enjoy this with us. Again,
Thank you for the invitation to share some of my time, and kind of nice to interact with people.
yes.
IEEE.
Yes.
Okay, take care. Thank you.
We like you, so we will invite you for sure for the next coming ones.
Yeah, if you want, there's one on economic power.
Economic power
Sam
for
will give
sure.
that presentation, the webinar.
For sure, we will love to hear that from you as well. Thank you so much.
Sure. Appreciate it. Thank you. Bye-bye.
All right. Take care, everyone. Have a good evening. Bye-bye.